Hello class, we're going to be discussing parallel and perpendicular lines, and to remind some of you, this is all we are covering today, but also we need to remind ourselves because it is apparent that some people, I'm not going to mention names, have forgotten slope-intercept, point slope, and standard form. Intercept. I'm going to write this shorthand after this point. Y equals mx plus b. Point slope would be y minus y1 equals slope times x minus x1. Now, can you plug in any point to this? Yes, and then there's standard form. And standard form would be ax plus by equals c. Now, you should be able to transfer between any of these three. For our parallel and perpendicular, you're going to put it into slope-intercept, okay? Okay. That will just be the easiest way of writing it. So slope-intercept will be what you are covering, okay? Now, parallel and perpendicular lines. We aren't going to talk about converses, inverses, any conditional statement like that. We're going to leave it as it is. But there are two statements that are true. They're the same thing. If two lines have the same slope, then they are parallel. If two lines are parallel, then they have the same slope. So these two things are statements that are biconditional, meaning if two lines, non-vertical lines in the same plane, have the same slope, then they are parallel. If two non-vertical lines in the same plane are parallel, then they have the same slope. Thus, these two are biconditional statements, okay? Now, let's look at how you're going to solve this, okay? Firstly, because we know parallel lines have the same slope, it's pretty easy to find the parallel line given a point and our slope. So we have a line y equals 3x minus 1. Now, we are going to find the parallel line that passes through this point. So what we're going to do is we're going to write a new line with a b, different b. We're just going to plug in negative 5 for y, negative 3 for x. So we get negative 5 equals 3 times negative 3 plus b. Solving this out, we get negative 9 plus b equals negative 5. Add 9 to both sides. 4 equals b. So our new equation is y equals 3x plus 4. And so this line, as you can see, our lines have the same slope but different y-intercepts. And that's going to be pretty much the case for all parallel lines. We're going to cover another example at the end of this video, so bear in mind we will cover that. Now, perpendicular lines, this is another crucial idea that will follow up throughout math. In fact, if you continue, you'll find out that perpendicular lines is a concept that not only goes throughout most all of math, but actually is quite fascinating. And, in fact, is used by, unfortunately, people in an incorrect way. So, we're going to start with our point, 3 comma 2, 3 comma negative 2. Okay. Now, this negative 2 comma 3, negative 2 comma 3, this line, okay, it's much easier to draw lines this way. Okay. It's -1, -2, 3, 2, 1. Okay. So this is going to have a slope of -3 and over 2. Okay. So -3 over 2. Now what's the slope of our perpendicular? Our perpendicular is going to have a slope it's just me plotting. Okay. So this is going to go through the point 3, 2 with a slope of 2 over 3. Notice, what's the comparison between these two? Well, first off, this has flipped, so it's a reciprocal. Secondly, it's a positive where it was a negative. So it is a negative reciprocal is the answer. Okay, so notice there's a right angle here. That's what perpendicular means. It is two lines on the same plane that intersect at a right angle. That is perpendicular, okay? Now, you would not need to know the right angle stuff yet, but it will be crucial later on. Anyway, we're going to see how this is defined. So two non-vertical lines are in the same plane, have the slopes that are negative, reciprocal. The way you can view it is if you have slope m over 1, then m over 2 equals -1 over m over 1. Okay? That is a negative reciprocal. Okay, you flip it. Everything on top goes to bottom, everything on bottom goes to top. That is negative reciprocal. Okay? This is perpendicular. Okay? Okay, that is what we're going to be looking at. So let's figure out, first, we're going to figure out what is perpendicular. We're going to solve for it. So let's take an example. Okay, let's determine whether the lines are parallel, having the same slope, or perpendicular, negative reciprocal. Okay. This is A, then B is x plus 5y equals 2, and C is negative 10y minus 2x equals 0. So first I'm going to write these two as slope-intercept. So we get y, we have 5y equals negative x plus 2. Y equals negative 1/5 x plus 2 over 5. Don't know if you can see that. You can see that. Okay. And then this one is negative 10y equals 2x. Divide by 10. Y negative 10. You get negative 1 over 5 x. So y equals negative 1 over 5x. So perpendicular. Perpendicular is if you have 5, what's the perpendicular slope? So if m equals 5, then m2 will equal negative 1 over 5. Okay, that's negative reciprocal, right? We put a negative in and we flipped it. Which ones have this slope? Well, B and C. So B and C are perpendicular. So line A is perpendicular to line B and line C. Okay? Now, what about parallel? Well, if m equals 5, then that would mean m2 equals 5. Do we have any m2s that equal 5? Well, no. Not this one. And not this one. Okay? So that would leave just this one. So that would have no parallels, okay? But what about B and C? Are B and C parallel? Well, if we look at their slopes, slope C is 1 over negative 1 over 5, and slope B is negative 1 over 5. So our conclusion is line B is parallel to line C. Okay? Line B is parallel to line C. Line A is perpendicular to line B and line C. Okay? That is our conclusion. Let's do some practice problems. So we'll do one practice problem. I'll upload this. You'll know how to solve for perpendicular, okay? Really quickly. Okay, let's take our earlier line. Okay? Okay, right here. So let's say we have negative 2, comma 11, and we are finding the perpendicular to this line. So first we have to find our slope, m equals negative 1. So that implies that m2 equals positive 1, okay? Because it's negative, so it'd be negative 1 over negative 1, which then becomes positive 1, okay? That's how we've solved this. Okay, so we get y equals x plus b. Plugging in y and x, we get 11 equals negative 2 plus b. So 13, sorry, not negative. 13 equals b. So then our answer is y equals x plus 13. And that would be our answer for perpendicular to this line. Okay? That's perpendicular. Okay? That's it for now. I hope you guys are able to see it. This is some basic concepts. We'll talk about how this is our building block. Okay? Okay, thank you guys so much. We will not cover the word problems today. I could do that problem. Okay, example 4 is another one very similar to what I just did. You could find the perpendicular line that passes through the point. It's pretty straightforward. It's not that hard for you to do, so feel free to try it out. Okay? Okay, see you guys shortly. Bye.